Okay, I'm on page 217 in the book, so if you need to take a moment to get your book out and open up page 217, then I'll wait a moment on the video, and if I get going too fast at any point in time, you can just pause the video, okay, or ask to have the video paused, okay? I'll try and take my time. So hopefully you're at page 217. And when we take a look at this graph, it's definitely a polynomial graph. Remember, we talked about how they're curvy, got all these different waves in them, okay? And so the first thing it asks is consider the a value. Well, since it's going to head off towards positive infinity at the end, a must be positive. A has got to be greater than 0 or positive. It has to be. If the value of a is negative, the very first, so we know that it would be y equals some ax to the, I don't know, it could be x to the fifth or whatever. Blah, 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 blah. We know the a value has to be positive because it finishes up towards infinity, okay? And behavior as x approaches infinity, infinity, y is going to approach infinity, okay? Now, is the degree of even or odd? Well, it's got to be an odd function because we know that it finishes up and down, okay? We talked about that, right? Remember the little funny thing where I do my little stand? It's got to be an odd function, some x to the fifth, I'm pretty sure, okay? Could it be cubic? No. I'll tell you why. Can't be cubic because I already have 1, 2, 3, 4 zeros, and that's a double root, so it's really 5 zeros. So can't be cubic. I think it's actually to the fifth power. I think the degree must be 5 because I've got 1, 2, 3, 4, 5 roots. I've got 5 roots. Therefore, I'm pretty sure it's got to be the fifth degree, okay? Domain, well, that's pretty easy. Domain's all real numbers because it goes forever and ever and ever. So domain simply is x is equal to all real numbers, right? Goes on forever in both directions, right? If you like the cursive R, I don't mind that either. Cursive R for all real numbers. That's a nice little symbol, okay? And the range is the same. It goes forever up, the height, and forever down. So I'd say the range of that is that y or f of x, y or f of x is equal to all real numbers, okay? Great. Now extrema. Now extrema, we're looking for the tops and bottoms of the hills. Okay, let me get a different color marker here so we can go ahead and mark the extrema. But I'm pretty sure extrema, here's one extrema, that's a relative min right there. Let's call that point A. I know I got another one right here. Let's call that point B. That's a relative minimum. I got another extrema here. Let's call that point C. And then that's called a relative minimum. I'm sorry, maximum. And then I got another point D here at D. Okay, I'd call that a relative minimum. So let's determine. So I've got 1, 2, 3, 4. I've got 4 minimum, 4 extrema. And oftentimes, it's 1 less than the degree. Oftentimes. Sometimes you get some weird graphs, but oftentimes it's 1 less than the degree. So determine the absolute extrema. So determine the number of them. I got them. Determine the number of relative extremas in this graph. I did that. Determine the number of absolute. Oh, the absolute is none. Absolute means, you can find the top of the hill. It was like the very top of the hill. For example, let me just show you an example. There are none. There are none. If I had a graph like this, you could say that might be the very top of the hill, right? But we don't have like that because this one goes up forever. You're never going to have an absolute max going off to infinity. This one goes forever down, so you're never going to have an absolute minimum, okay? So none, just none, okay? Use estimation to identify the intervals where the graph is increasing, okay? So first of all, estimation. Now, increasing, decreasing has to do with the x values. Let's write that down. Increasing, decreasing. The intervals have to do with the x values. Please write that down. The x values, not the y values, it's the x values. It's the x values are increasing from here to here. Yes, the graph's going up, those are the y's, but it's the x values. Okay, so we know it's going uphill. Uphill from negative infinity to point A, right? So it's going uphill from negative infinity, point A, goes from negative infinity to point A. Now, point A, what's the x value of point A? Well, we think it's about -3. So we're going to say from negative infinity to negative 3, okay? We also know that it seems to be going up from B to C. Also from B to C, it's increasing, it's going uphill. I'd say that's from negative 1 to maybe 1/2, maybe. Negative 1 to maybe 1/2. I'd say that's from negative 1 to maybe a 1/2. And then I would say we're also going uphill from D to infinity. From D to infinity, we're going uphill. And I'd say that's probably from maybe 2.5 to infinity. So from 2.5 to infinity. Okay? And I can write this one like this one. Negative infinity to negative 3. Okay? Where's it going downhill? Well, it's decreasing from A to B, right? From A to B, from A to B, it's decreasing. So it's decreasing from A to B, so it's decreasing from, I'd say it's probably a negative, maybe I had it wrong, negative 3, might have been negative 2.5, that's right. Negative 2.5 to maybe negative 1, so I'm going to go from negative 2.5 to maybe negative 1. And it's also going downhill from C to D. So that's from the interval between maybe a negative, probably have these off, probably a 1/2 to maybe a 2.5, from maybe a 1/2 to a 2.5. Okay, increase and decrease. Okay, great. All right, let's turn the page. Now, on the other page, I want to talk about imaginary roots more than anything. Okay, I'm going to talk about what we call imaginary roots. This is what I really want to talk about, imaginary roots, okay? Now, check it out, okay? It's got a lot of squiggles. It goes up, down, up, down, up, down, okay? It's got a lot of squiggles, okay? It's probably a x to the 6th power, but I'll show you why. It goes through once, goes through right here. There's a 0. So here's my zeros. I want to look at the zeros. I'm going to mark them. There's a 0. There's a 0. There's a 0. There's a 0. Now, you see right here, in theory, this graph really wants to go up here, across, and doesn't. It kind of comes up and down, okay? Right here is an attempt by the graph to go through the x-axis, but it doesn't. It doesn't. It's still an x to the 6th power, okay? But the problem is right here, this part, it wants to go up and cross through and have some real x-intercepts. These are almost intercepts, almost, but they don't go through. They don't touch. They're down below. These are going to be my imaginaries because they imagine them going through the x-axis. They don't. They just want to. They try to go up, but they don't. So those are my imaginary roots, okay? Right there. Those are my imaginary roots. So, all right, a value. Well, let's go back to this. This graph is going down as x approaches infinity. Y is approaching negative infinity, so the a value, and I'm pretty sure it's an x to the 6, so fx equals some negative a x to the 6th, blah, 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 blah. Okay? The degree of the function, I'm pretty sure is 6, so it's going to be even. Okay? Because it finishes down, it has either, remember how we talked about either they both go up or they both go down, right? Could this be a 6? I'm saying yes. Yes, I think so, yes. Could be a 6 because you've got 1, 2, 3, 4, and these two right here are your 5, 6. Those are your other roots, yes, because it could have 4 real roots. 4 real roots. 4 real roots. You ready? 1, 2, 3, 4. Those are your 4 real roots, and then what we call 2 imaginary. Okay, 2 imaginary. Which are those two right there? Right there. Those are your 2 imaginaries. Okay. Domain. Now, domain is still going to be all real numbers, so we're going to say x is equal to all real numbers. But the range, or x equals the cursive r, but the range is different, right? It seems to have a height of maybe 2.5. I'm just going to guess at 2.5. So the range is probably going to be f of x is less than or equal to 2.5. That's the same thing as y, right? Fx and y are the same thing, okay? Okay, extrema. Well, okay, let's see. I'm going to extrema. Now, extrema are the top and bottom of hills. if they're relative, okay? So let's see, I've got 1, there's point A, B, point C. That's a relative. 1 also, point D and point E. Again, 1, 2, 3, 4, 5. 5 often is 1 less than a degree. Okay. Okay, so determine the number of relative. So there's 1, 2, 3, 4. There's 5 of them. 5 relative extrema. The number of absolute extrema, there's only one. There is an absolute max at point C. Point C is an absolute max. Okay, so point C is the absolute max. It's the top of the hill, maximum. Okay? Okay? Use estimation to identify the intervals where the graph is increasing. So again, we're talking about x values. X values, okay? And I'm going to use interval notation. I like interval notation. That's what I did on the previous page. I actually used interval notation here. Interval notation is kind of a handy way to do it. Sorry about that. I'll go back. Interval notation looks like this. Okay, so first of all, from negative infinity to point A, and again, it's the x values. From negative infinity to about, I'm going to guess negative 3. We're just going to S. A maybe negative 2.5. We're just going to guess. Negative 2.5. It says estimate. So I'm going to go from interval notation from negative infinity to about negative 2.5. It's increasing. It's also increasing from B to C. So that's from it's also increasing from B to C. And so if I estimate from B to C, okay, I think it's going to go from B to C. It's increasing. So if I go from B to C, I'm going to guess maybe negative 1.5 to about 1/2. Okay, so negative 1/2 to 1/2. So I'm going to go from negative 1/2 to no, actually negative 1/1/2. Negative 1.5. My bad. Up to 1/2. Up to positive 1/2. Okay, that's a negative 1.5. So you guys, it's a little sloppy. There you go. And then it's also increasing from D to E. It's going uphill. It's increasing, okay, from D to E. Probably negative 2 to probably maybe, I'll say negative 3. No, positive 2 to 3. Positive 2 to positive 3 on the x values. Positive 2 to positive 3. It's increasing, okay? Got it. Now, decreasing. Decreasing. Where's it going downhill? So from A to B. Okay, it's going downhill from A to B. I'm going to use interval notation. It's like these brackets. You notice that? These brackets. So it's going downhill from A to B. So what did we say that was? About negative 2.5 to about negative 1.5. Negative 2.5. Negative 2.5 to negative 1.5. It's also going downhill from C to D. From C to D, it's also going downhill from C to D. And I think that is from positive 1/2 to 2. Positive 1/2 to 2. Positive 1/2 to 2. And then finally it's going downhill from E to infinity. So it's going to go downhill from E to infinity. And point E is 3, so it's going to go from 3 to infinity. Okay, there we go. A little bit confusing. You know, we've had this on our Mathia. Please work on that Mathia because Mathia does it well. So look at Mathia as well, okay? I'm going to pause this video.